This is Algebra 2, Unit 4, Lesson 10 on logarithm laws. Now, logarithms, remember, we've been saying, are exponents. It is the inverse of the exponential property. So the laws that govern exponents also apply to logarithms, since the laws of government should be similar to that govern exponents. So let's take a look at the laws. All right, we know the exponent version, the product law says when you multiply the same base, what do you do with the exponents? You add them. B to the x times b to the y is b to the x plus y. Now the same thing is true for exponents. If you have a product of a log, it is equal to the sum of the two logs. All right, so log b of x times y is equal to log b of x plus log b of y. So you can take each of these individually and add them. Now you can also go in reverse order. If you have this, log of b of x plus log of b of y, you can rewrite it as a product of laws. It goes both ways. Okay, quotient law says b of x divided by b of y, when you divide the same base, you subtract the exponents. So if you have a quotient of a log, it's equal to the difference between the logs. Now notice it's x divided by y, it's x minus y here. So since the logs are exponents, we're doing what the exponents would do. When you divide, you subtract, and vice versa. All right, the third law we know is the power rule. When you have power to a power, b to the x raised to the y power, you multiply the exponents, b times x times y. b to the x times y, sorry about that. So if you have the log of something raised to a power, it is equal to the product of y, or the exponent, times the log. Basically, the exponent goes out in front like this. So it's y times the log. All right, so remember, because logs are exponents, the rules are basically the same. When you multiply, you add. When you divide, you subtract. Power to a power, you multiply. So let's work out some problems that deal with the logarithm laws. All right, exercise 1. Which of the following is equal to log to the base 3 of 9x? All right, now log to the base 3 of 9x is a product. It can be written as log to the base 3 of 9 times x. So if we are doing a product, when you're thinking exponents, you're doing a product, what do you do with the exponents? You add them. So this can be rewritten as log to the base 3 of 9 plus log to the base 3 of x. Okay, now notice that answer isn't there, but what is log to the base 3 of 9? 3 to what power is 9? Well, that would be 2. Plus log to the base 3 of x. All right, so which one is that? It would be number 3. Okay, the expression log of the x squared over 1,000 can be rewritten in equivalent form as. All right, so let's think about what we have here. We have log to the x squared over 1,000. Okay, well, that is a quotient. A quotient of a log, when you for exponents, when you take a quotient, you subtract the exponents. Okay, so that's going to be log to the x squared minus log of 1,000. Okay, now this is log x squared. This is a power. So when you raise a power to a power, you multiply the exponents. So the exponent will actually go out in front of the log. So it's going to be 2 times log of x minus log of 1,000. All right, so now notice here, we've done the 2 powers of logs when we do that. Now to check our answer here, we don't have the answer here, but we have 2 log of x minus log of 1,000. Now notice right here, there's no number there, so that's automatically base 10. So it's 10 to what power is 1,000? It would be 3. So this would be 2 log x minus 3. If you're not sure, you can grab your calculator and do log of 1,000. Is 3. So there we go. All right. So 2 log of x minus 3 would be number 1. Okay, now let's try something a little bit different. If a is equal to log of 3 and b is equal to log of 2, then which of the following correctly expresses the value of log 12 in terms of a and b? All right, so what we want to do is we want to be able to write log 12 using 3 and 2. All right, so we know log of 12 is equal to, we could rewrite it as a product. Isn't 3 times 4 equal to 12? Yep, 3 times 4 is equal to 12. All right, so, but we have a log of, we can do a log of 3. How are we going to get the log of 2 in there? What's 4 is equal to? Well, it would be log of 3 times 2 squared. That we can use a base of 2 for. All right, so we want to take this and rewrite it in expanded form. All right, so log of 3 times 2 squared. This is a product, so what do we do with the logs? We would add them. So this would be log of 3 plus log of 2 squared. All right, now what do we do with the exponent? We multiply, so it goes out front, so it'll be log of 3 plus 2 log of 2. Okay, now, according to what we have given, a is equal to log of 3, so this is going to be a, and b is equal to log of 2. So this is going to equal a plus 2b, which would be number 4. All right, so we're just applying the laws of logarithms. All right, so we've covered all the rules. Product, quotient, power. And we've done both ways. All right, so let's try another one. All right, this one might take a little bit of thinking. Which of the following is equivalent to log to the base 2 of the square root of x divided by 5y? All right, so what we need to do is, first of all, expand our log so that we can see it. All right, so overall, this is a quotient. So we are going to have to subtract. So this is going to be log to the base 2 of x minus log to the base 2 of y to the 5th. All right, now, the square root of x. How can we write that using an exponent? Well, we know log to the base 2 of x, power over root. The power is 1, the root is 2, so this is going to be x to the 1/2. Okay, so now I have exponent here. This is the power, it goes out in front, multiply, 1/2 log to the base 2 of x, minus, and this one also goes out in front, 5 log to the base 2 of y. All right, so we have 1/2 log to the base 2 of x minus 5 to log to the base 2 of y. That is number 3. All right, it just takes a little practice. You have to think in reverse a little bit, because exponents and logarithms are inverses. The rules are basically the same. You can work them either way. All right, the value of log to the base 3 of the square root of 5 divided by 27 is equal to. All right, let's try this one out. Overall, again, it's a quotient, so that means we're going to have to subtract. So that's going to be log to the base 3 of the square root of 5 minus log to the base 3 of 27. Okay, now, I need this to be an exponent, so again, the square root of 5 would be 5 to what power? Again, power over root, it would be 5 to the 1/2 power. All right, now, this is an exponent, so it would have to be multiplied, so it goes out front. 1/2 log to the base 3 of 5 minus log to the base 3 of 27. Okay, so we don't have that answer there, but we have log to the base 3 of 27. Is 3 to some power 27? Yeah, it is. If you're not sure, grab your calculator, use your log base key, alpha, the zoom key, oops, that's the wrong one, alpha, the window key, number 5, you can do log to the base 3 of 27, but you should know that that's going to be 3, because 3 to the 3rd is 27. So yeah, it does equal 3. But if you're not sure what it equals, you can always use your calculator. 1/2 log to the base 3 of 5 minus 3. Okay, so which one is that? Well, if I want this to be a answer here, none of these answers match up. So I probably need to do some combining here when I do that. So if I put this over 1, I want to get a common denominator. What's my common denominator going to be? So this would be 1/2 log to the base 3 of 5 minus 6 over 2 for that. So when I combine this, I get log to the base 3 of 5 minus 6 all over 2. All right, so that would be number 1. So there we go. So we just combined our terms to do that. All right, let's do one more and then we'll save the rest for the next class. F of x equals log of x and g of x equals 100x cubed. Then f of g of x equals. All right, so f of g of x means we take g of x and plug it in for f of x. So we are looking for f of 100x cubed. So we're going to take this, plug it in here. So that's going to be log of 100x cubed. Okay, so I plug that in for here for x. Okay, now I need to expand this. Log of 100x cubed. 100x cubed right here, this is a product. So that's going to be log of 100 plus log of x cubed. Okay, then I have an exponent here, so that's log of 100 plus 3 log x. The exponent goes out in front. Okay, so now I need to evaluate this. What is the log of 100? What is your base when it's just log? It's base 10. All right, so remember the imaginary 10 right here. So 10 to what power is 100? That would equal 2. And then 3 log of x. And again, if you don't know what log of 100 is, you can grab your calculator, hit the log key, because that's the base 10. Log of 100 is 2. Okay, so this is 2 plus 3 log x. That would be number 4. Okay, so you get the general idea. See if you can work out 7, 8, and 9, and we'll go over them in class the next day.